Okay, Mr. Ismail. Sorry about this.
Okay.
Okay, so Asha and Zaki here. Let me get the rest.
Okay, assalamu alaikum. Okay. Today we'll carry on with the answering questions from the past year's papers. This topic is called loci. Let me just review a little bit. Loci. Loci is the plural of locus, which means a set of points, possible points satisfying the condition. What do I mean? If we have a 1 point and we say we need a locus of points 3 centimeter from this point A, 3 centimeter from A. So where are the 3 centimeter from? Where are the possible locations for the points that are 3 centimeter from A? So you can measure 3 centimeter. This is a possible point, but that's not the only point. You can have it here. So there are many points that can be drawn satisfying this condition, 3 centimeter from A. And if you just join all the points, it will be a circle. So a distance, this is 3 centimeter is a distance. Distance from a point. The locus is a circle. Radius of the same distance, understand? So if this is 4 centimeter, and this is the point A, so you just measured 4 centimeter, and all the 4 centimeter from A will form a circle. The circle, this is the distance is going to be the radius. So whenever you see what they ask for distance from a point, you will get a circle, radius of the same distance. We can have equal distance, equidistant from 2 points. So what is this? This is the first one. This is the first case. Second case, distance from a point, equidistant from 2 points. Equidistant means equal distance. If I have a point A and B, and they ask you, find all the points that are equidistant from A and B, means must be equal in distance from A and from B. A lot of students can see this is the midpoint of this. You can see that it's going to be equal in distance here. But that's not the only point that can be equidistant. I can have a point here where the distance here and here are equal. I can have the point here, the distance between the A and AB are equal. I can have the points up here, distance between A and B are equal, here, here, here. And you notice that if you were to join all the points, you were going to get a straight line that is a bisector of these 2 points. So this will result in a perpendicular bisector. So whenever you get this question, you need to find the perpendicular bisector. The line is drawn and somewhere in the middle, and you're going to get how to draw that line. But to draw that line, you need to take a pair of compasses and you mark, make sure that it's more than half. You mark this way and mark this way. Then you go with the same distance, go to B, and you mark this way and this way. And when you join, you will get the perpendicular bisector. These two will be equal. Yeah. So that's how you draw the perpendicular bisector, by using, do not use ruler only, you must use compasses. How about another case? Equidistant from 2 lines. This one is equidistant between 2 points. This is a line. So normally the line will be this, like that. So A, B, C. So equidistant between AB and BC. So where the equidistant? The equidistant, this one is you need to bisect the angle. So take a pair of compasses, you mark here, and then with the same length, you mark. This is the angle bisector. So this one is angle bisector. So if it's equidistant from 2 points, it is going to be perpendicular bisector. Equidistant from 2 lines is going to be angle bisector. I forgot to show you one more. Actually, this is number 3. There's a number 2 equidistant between that. This one, there's a number 2 here. Distance from a line. So if you have a line and they tell you 2 centimeters from this line, 2 centimeters from this line will be around here, here, here. 2 centimeters is measured like this. So it's going to be another line that is parallel. But these are not the only points. You can also have points below. So this is 2 centimeters, 2 centimeters. So whenever it's distance from a line, you will have parallel lines as the answer. How do you know whether it's a point or a line? So if they say 3 centimeters from X, now this is just 1 point. 1 point is a point. 3 centimeters from X, Y. This is going to be a line because it means this is X, this is Y, so this is a line. So there you are. How you tell whether it's a line or or a point is from the lattice. Okay, so these are the four possible locus that you learn in high school, in N level and O level. So distance from a point is going to be a circle. Distance from a line, parallel lines above and below. Equidistant, which means equal distance from 2 points, is perpendicular bisector. Equidistant from 2 lines is going to be angle bisector. Okay, so let's answer this question. The diagram shows a quadrilateral. Quadrilateral means 4 sides. So A, B, C, D. Okay, then on the diagram means on the diagram itself, you have to construct the perpendicular bisector of BC. So they didn't tell you about equidistant, whatever. So they just tell you to construct. So this is easier. How to construct perpendicular bisector of BC. You got to see where BC is. This is B, this is C. So this is the line that you're gonna bisect. You're gonna bisect this line. Bisect the line means you got to find the line that is in the middle, like this. So how do you do that? You just focus on BC, and then you go and get a pair of compasses. You mark here and here with the same distance without changing the compasses. You mark here and here, and then you join. This is the answer to part 1. So in the exam, when this is the case, you have to write down here, A, part 1. This is your answer, like that. 2, construct the bisector of angle BCD. Where is this angle? BCD. Oh, this angle, this angle. So how to bisect the angle? Just now we did already. To bisect the angle, you take a pair of compasses, you mark any length, you mark this way. With the same length, you mark this way and this way. From here, you mark one, and from here you mark the other side. Okay, now you join. So this is the answer to A, part 2. So I write down here A, part 2. Okay, now they ask you part 3, shade the region. Region is area like this. This is region. Shade the region inside A, B, C, D. So inside this, inside A, B, C, D. So only inside here we are interested, and we don't outside. That is closer to BC than CD. Where is this? Which line is it? So this one here, after drawing A1 and 2, it is definitely related to what you have drawn. So you want to have a closer BC than CD. So here. So let me just draw it out so that it won't be so confusing. You have drawn this angle bisector. This is BC and this is CD. So which region? Is it this region? 1 or region 2, where it's satisfied that it's closer to BC than CD. So obviously, if I have the point here, this point is closer to BC than CD. Any point here, closer to BC than CD. Over here is closer to CD than BC. So your answer is this side. This is the region that you want. Okay, but you have another part. They say closer to B than D. That means you look at this bisector that you have done, this B and C, B and D. No, there's a mistake. It should be B and C, because they ask you to draw this bisector BC. Yeah, so this one should be D. Okay, C, sorry. So which of these, now let's look at this line. This is B, this is C, and this is gonna be your bisector just now you draw. Which point, which region is closer to B than C? So closer to B than C is this side. Therefore, which part is this one and this one? You must shade. Let me just finish this one here. So you want a region that is this side and also that side. Therefore, the answer is here. Let's check. If I take this point, is it closer to BC than CD? Yes. And is it closer to B than C? Yes. So this is the region that you need to show as the answer to part 3. Okay. B. The diagram is a scale drawing, a scale, if you recall, scale of a park A, B, C, D. If you remember what scale is. Scale always have this 1:100. What does it mean? It means that on the left is the map, on the right is the actual. And how do you start? You always start with 1 centimeter, 100 centimeter. Make sure they are the same. And so then they will start asking you questions. Okay, we've done this last week. So similarly, here we have this, the minute they say a scale diagram, it means you can measure or you have to measure. So they say here 1 centimeter represents 40 meters. So, okay, so you have 1 centimeter. This one is, the scale is not written in this form. They tell you 1 centimeter is 40 meters. So, okay, take it. No need to worry already. No need to worry about this. So 1 centimeter is 40 meters. Find the actual length or distance between A and C. Where's A and C? So I'm going to erase this so that, because I'm teaching, so it's easy to see. So this is, remember, this is on the map or on the diagram. This is the actual. So since I want to find the actual distance between A and C is here, A, C. So I need to find actual distance. What do I do? Yeah, you need to measure this distance. But don't measure with a ruler. A lot of students measure with ruler, and that's where you get into trouble because you're going to miss because of parallax error. If you study physics, parallax error means something you cannot, you must see actual right at the top. You cannot see from the side and you'll get all things wrong. So what you need to do, the best way will be to get a divider. I don't know whether you know a divider or not. Divider is this one. Like compasses, but both of them are, the end point is needle, like this. You can also use a compasses. What you need to do is you open this, you stretch it up, and one put at A, one put at B, C, like this. Then that is the distance. Then you take that, don't move, and you put it on a ruler. Then you will see what is the distance given. All right. Now, so this one I don't have the ruler and all that. So let's say this is a 5.5 centimeter. So what's the answer? So I want this answer, which is, I can call it Y. What to do? Now, remember, we always come to this side. We must check centimeter, centimeter, same, meter, meter, same. I cross multiply. 1 times Y, Y, 40 times 5.5. And I will get the answer in meters. So this is how you do this kind of diagram. This is locus or drawing. This one is scale. Very simple. And remember, your locus only 4 that you know, you must know, and they are very simply just distance from a point, distance from a line, equidistant from 2 points, equidistant from 2 lines, and remember the shape. Okay. Next, we have this. This is a simple one, starting of the next paper. I'd like you to do this because these are not anything that is difficult. Can you please try and do this? Let's take 3 minutes to do this. Okay, this topic is very simple, this one. First, the top one, number one, is substitute. Quite simple, isn't it? For example, you're given P equals to 3H plus 7K, etc. K squared, for example. Then they say find P if H equals to 2, K equals to 1. So what does it mean is just whenever you see H, you put 2. Whenever you see K, you put 1. Like that. This is the substitution one. Very simple, huh? The next one that they can ask will be on express. So just now I have P equals to H plus K squared. I can ask you express H in terms of P and K. So what it means is you got to change this form and write down H equals, because you want X, H is in terms. So H equals, so you have everything, you put everything on one side, H on one side, the rest all must go to the other side. So you can see that if I keep H over here, this one I don't want. This one goes across to the other side, becomes P minus K squared. Now H is on its own. So H in terms of P and K is this. This is the answer, like that. You rearrange and make sure that you have just whatever they want to be alone, yeah? Or if they say what is express K in terms of P and H. So what do? Same, you keep K squared, because K squared is given. You don't want K squared, but you want K, but doesn't matter. You keep it first. You keep K squared, H goes across, P minus H. If you like K squared to be on the left-hand side, you just flip. But nobody asks us to find K squared. They ask us to find K. So how do you remove the square? Becomes square root, plus minus. Yeah. So this is expressing K in terms of P and H. So this is this topic on substitution and also expressing one term in terms of the other. Okay, let's start this one. How would you do this? So you're given P 4K, K minus 2H. So you're given that P small, yeah? So I must follow. You're given that K is 0.5, H is negative 1. So you just substitute. K is 0.5. You can put half if you want. Half minus 2 times negative 1. Okay. Now, half times 4 is 2. Half plus 2, because 2 minus 2 times minus 1. So half plus 2 is 2.5. 2 times 2.5 is 5 over 2. And so this is 5. You are allowed to use calculator, so you just use a calculator to get the answer. All right, that's quite simple. Next is express H in terms of K and P. Okay, how do you do? P equals to 4K, K minus 2H. This is going to be slightly complicated because the H is inside. So quite cumbersome. What you need to do is you open the brackets. There. After opening the brackets, you get this. Now you see, what is it you're supposed to do? I'm going to keep the H on its own, but H has all these. Doesn't matter. And H has the term negative. I make it positive by bringing it across. And the rest I keep 4K squared minus P. I just bring this across to this side to make it positive. Now what happens? I do not want 8KH. I just want H. That means to say 8K must go the other side. This is the answer. H in terms of K and P. Okay. Are you supposed to find age, etc.? No, nobody asks you to find, no number is given. Just have to rearrange and become like this. This is the answer for this one. Now, this 4 and 8 can cancel? No, cannot cancel. Yeah, they cannot cancel. You can cancel only if, like this can cancel. But this one, no. 4k squared minus p over 8k cannot be simplified any further. This is it. Okay, next question. Factorize. I think I taught you factorization. 2 terms, 3 terms, 4 terms. I hope you recall the 2 terms. You just take out the common factor, and there's a special one, a squared minus b squared. This is minus and with the square, and the answer is always a, b, 1 plus 1 minus. So for 2 terms, there's this. For 3 terms, remember you have to do this x squared plus 7x plus 10. So you got to do x 5 2 plus 5x plus 2x plus 7x. This must check with this. So this is for 3 terms. For 4 terms, it's the same as 2 terms. You need to take out the common factor. Okay, so I've done this already. I'd like you to try this on your own. 3 minutes. Okay, let's try. 2, this is how many terms? 1, 2, 2 terms. And there's a minus sign. So this one must belong to a squared minus b squared, where you can just later split it up. So what happened is, this a squared is good, but this 100 is not. It's not a square number. 4 is a square number because 4 is 2 squared. So what to do is, you must first think of all the first 2 terms. Are there any common factor that you can take out? Yes, you can take out 4. If you take out 4, you're going to have 25a squared minus 1. You check carefully. 4 times 25 is 100. 4 times 1 is 4. So there you are. You have this already. Next, this 4 is outside. This 25a squared minus 1 must belong to this category. You need to make sure that they are this square minus this square for you to get the AB. So A is obviously inside. 25, what number multiplied with itself become 25? So 5. So 5 times 5 square is 25, A square, and 1 is 1 square. And so now you have this in the form of A squared minus B squared. And this will equal to, just write 5A1, 5A1, 1 plus and 1 minus. This is the inside. The 4 is still there. So you write down 4, 5A plus 1, 5A minus 1. So this is the answer to this factorization of 2 terms. So look carefully, because 100 is not a square number. That means you've got to take out some numbers to make it into a square, and indeed it leaves you with 25. Now with the 4 terms. How to do 4 terms? Now 4 terms, you do 2 terms, 2 terms. Focus just on the 2 terms, and you get it correct. So look at this first 2 terms. What is common there? You can see that P is common. If I take out P, I will have 5x inside there minus 4y. That's the first step. Next, you look at these last 2. So that last 2 has, I'm going to just rewrite in another color, black. So I'm going to write minus. What is common here? I see Q is common and also 2 is common. 2Q. And what is left if I take out 2Q? I'm going to left with 5x. And then if you look carefully, I'm going to left with 4y. And you may write down plus, I think. Yeah. Now, what must you do at this point? At this point, I mentioned to you, you must always stop, look at the inside of the brackets. They have to be the same. They're not the same. Something is wrong. The question cannot be wrong. You are the one wrong. So what you do is you check. And if I try to open up, this times this is minus 10qx. This times this is minus 8qy. The question is plus, therefore I'm wrong. This should have been minus. Now you check. Yes, indeed. Inside is 5x minus 4y, 5x minus 4y, and so they are the same. And so you write down, you take it out, and the remainder, P minus 2Q goes here. This is the answer to factorization of 4 terms. If you don't believe, you open this up and you see that you get this exactly the same. Let's check. 5xp minus 10qx minus 4py plus 8 qy. And indeed, they are the same. This one, xppx is same. Minus 10qx minus 4py plus 8qy. So it's correct. Okay. Now we look at, this is the product of prime factors. Okay, let's look at the terminology. Factors and multiples. So when they say what are the multiples of 3? Multiples of 3, you just use multiplication table of 3. So 3, 6, 9, 12, 15, so on and so forth. That's multiples of 3. Multiples of 5, 5, 10, 15, 20, 25, etc. So that's the meaning of multiples, multiplication table. Now factors is slightly different. Factors means what two whole number multiply together to give that number. So that is the meaning of factor. So if I ask you, what are the factors of 6? So the factors of 6 are, so you go and find what are the numbers that can multiply with to multiply together to get 6. 1 times 6. You can also have 2 times 3, and then 3 times 2, so go back again. So the multiples or the factors of 6 are 1, 2, 3, 6, like that. So you just list 1, 2, 3, 6. This is the factor of 6. How about the factors of 12? So 12 are 1 times 12, 2 times 6, 3 times 4, then 4 times 3, go back again. So the factors of 12 are 1, 2, 3, 4, 6, 12. Okay, so that's the meaning of factors. What two numbers multiply to give you that number? Multiples are the timetable. I'd like you to try and give me, what are the multiples of 18? Can you find for me the multiples of 18? Sorry, not multiple. Factors of 18. Very simple. Let's do this in 2 minutes. So to find the answer, multiple factors of 18, you go and find what two numbers multiply to give you 18. They are 1 times 18. Then you go to the next number, 2. 2 times 9. You go to the next number, 3. 3 times 6. 4. 4 don't cannot. 5 cannot. 6. 6 is here already, so that's the answer. That's it. So the factors are 1, 2, 3, 6, 9, 18. So these are the factors of 18. I want to show you something. I'd like you to find the factors of the following. Find the factors of 7, factors of 11, factors of 19, factors of that's all. Okay, find these factors. Shouldn't be that. Thank you, Arsha. Do the rest. I want to show something. Something is going to come out. Okay. Zaki, what you're doing is multiples, Zaki. I want factors. Seven, 14, 21, 28. These are multiples. I don't want multiples. I want factors. Okay. All right. Good try. Thank you, Arsha. Let's wait for the rest. Okay. All right. So if you look for factors that two numbers multiply to give you 7, you only get 1 times 7. Nothing else. So the factors of 7 are 1 and 7. How about 11? Same. The factors of 11 are 1 and 11. How about 19? The factors of 19 is 1 and 19. Now what do we notice? We notice that these numbers have only 2 factors. One and itself. You notice? 1 and itself. So 7, 1 and 7. 11, 1 and 11. 19, 1 and 19. I can give you some more. 5, 1 and 5. 3, 1 and 3. So numbers that look like this, numbers that have factors, 2 factors, they have 2 factors, and 1 is one of them, and the number itself. These numbers have a special name and they are called prime numbers. Okay, you have come across this, I'm sure. You've come across teachers telling you prime numbers, prime numbers, prime numbers. What are they? The prime numbers are numbers that have only two factors, 1 and itself. Okay, so what do we notice? We notice that, hey, a lot of them are, all of them are odd numbers. Now, are all odd numbers prime? Now let's check that. We want to see all of them are odd numbers, then maybe all odd numbers are prime numbers. Now I'd like you to check for me and give me the factors of 9, factors of 15. These are odd numbers. Let's see whether they have 1 and itself as the factor. Find the factors of 9, 15, and maybe 21. You try? These are all odd numbers also. But let's see what the factors are. Are they prime? Let's check. You do it, fine for me. Okay, so the factors of 9. Again, what are factors? Factors are, you find, like say 9, you find 2 numbers, multiply to give you 9. That's factors. You find 2 numbers, multiply to give you 9, like that. This is our factors. So first, you always start with 1. 1 times 9. Okay. Then you go 2. 2 cannot. 2 times what? Give you 9? Nothing. So you go to 3. 3 times 3 give you 9. Then that's it. 4, 5, all cannot. So you stop. That's it. So what are the factors of 9? The factors of 9 are 1, 3, which is repeating, 9. So there you are. Let's try 15. How to do 15? 15. What 2 numbers multiply give you 15? Like this. These are factors. So start with 1. 1 times 15. 2. 2 cannot. 3. 3 can. 3 times 5. 4 cannot. 5. 5 there already. So this is it. What are the factors? 1, 3, 5, 15. These are factors. 21. 1 times 21. 3 times 7. That's it. So 1, 3, 7, 21. Now, what's my point? I said just want all the prime numbers are odd. That means, can we say all odd numbers are prime? No. Look at this. How to be prime? To be prime, you must have the factor 1 and itself. 1 and itself. 1 and itself. 1 and itself. This one is no. You have more than 2 factors. You must have 2 factors only, but these are more than 2 factors. So these are not prime numbers. That means you cannot say all odd numbers are prime. Wrong. Okay. Now, if you are confused again, let's recall. Factors are like this. What 2 numbers multiply together give you that number? That's factor. Now multiples, you just think of multiplication table. So multiples of 8. What is it? Multiples of 8 is 8 times table. 8, 16, 24, 32, 40. This is multiples. These are all multiples. Multiplication table. What's the multiples of 2? 2, 4, 6, 8, 10, 12. These are multiples. Multiplication table. Factor? No. Factor, you must find 2 numbers multiplied to give you that. So factor of 18. What's factors of 18? So you're going to find 1 times 18, 2 times 9, 3 times 6. That's all. So 1, 2, 3, 6, 9, 18. So these are factors. All right. So we have already dealt with prime numbers. And what about the number 2? Can you write for me the factor of 2? What 2 numbers multiply to give you 2? What are the factors of 2? 1 and 2, right? Hey, what happens? 2 has 2 factors only. The number 1 and itself. Number 2 is a prime number. This is a very important discovery. This is a very important thing to know. The number 2 is prime. But number 2 is not odd. Yes, number 2 is the only even prime number. Number 2 is the only even prime number. Okay, good. So what about the number 1? Is 1 a prime number? Let's list the factors of 1. Can you write for me the factors of 1? What is it? Okay, the number 1 has a factor 1. 1 times 1. Only 1. Therefore, this is a factor. Is 1 a prime number? Remember what is the property of a prime number? Prime numbers must have 2 factors. 1 and itself. 1 and itself. 2 is prime. 1 and 7. 7 is prime. 1 and 19. 19 is prime. The number 1 has only 1 factor. The number 1 is not prime. Okay, 1 is not prime. Okay, then let's list all the prime numbers then. So the prime numbers, remember prime numbers, the definition, have 2 factors. 1 and itself. So what are the prime numbers? The smallest prime number happens to be 2. 1 and 2. The next prime number is 3. Now, 4 is an even number. Even number are not prime except for 2. Therefore, you skip to 5. 5 is prime. 7 is prime. Now, the number 9 is not prime because number 9 has 1, 3, 9 as factors. So number 9 is out. Number 10 is out. Number 11, the factor 1 and 11. 13, 1 and 13. 15 is not because 15 has 1 times 15, 3 times 5. It has a lot of factors. So no, 15 is out. 17, 19, 23, so on and so forth. These are all the prime numbers. What are prime numbers? It have 2 factors, 1 and itself. Right? These are the first few prime numbers. You learn this should be in primary school, yeah? And then you repeat it again in Sec 1. And then now it comes out in the exam. Okay. You understand? Prime numbers. First, we have factors, multiples, and then prime numbers. Okay. Let's look at this. Written as the product of its prime factors, 1, 5, 1, 2. Let me just review with you how to write product of prime factors. Let's just write about, say, the number 50, the product of its prime number. So what you need to do when you want to write the product, you do long division like this. You start with the smallest prime number. What is the smallest prime number just now? 2. Number 2 is the smallest prime number. 2. So you divide 50 by 2, you get 25. Then you try 2 again, cannot, because you have to have remainder, so wrong. So you go to the next prime number, 3. 3 also cannot, because you need to have remainder. You mustn't have remainder. Then you go to the next. So remember the prime number, 2, 3, 5, 7, 11. You try this, 2 first, then 3, then 5. 25 divided by 5 is 5. You try another one, 5, until you get 1. So 1, you get 1, you stop. And so the number 50 as the product of prime factors is 2 times 2 times 5 times 5, like this. This is writing 50 as the product of prime factors. But 5 and 5 like this, you can combine them. 2, 5, and 5 is 5 squared. So this is how you write the product of prime factors. Quite straightforward, yeah? Let's try another one. I leave it here so you can see the sample. You try and do for me 42. Can you write for me the product as prime factors? Do the same as what I did, but this time for the number 42. Let's try this. Okay. So what you do, you start from 42 like this, then you start from the smallest possible number. Prime number smallest is 2. Then you divide 21. Then you always try 2 again, but 2 cannot, no more already. So you go to the next higher, 3. 3 divided by 21 divided by 3, 7. Then you try 3 again, 3 cannot. Then you try 5, 5 cannot. Then you try 7. Oops, 1 already. Very good. So the answer is 2 times 3 times 7. Simple, yeah? Okay. Now you do 2 more for me. This is product of prime factors. You do 60 and 180. No, the one in, no, okay, can, 60 can. All right, try. Let's do both, please. 60 and 180. Please attempt. Okay, so 60, let's try. Start with the smallest prime number first. 2, let's give it 30. Get the smallest number again. 2, can 2 goes? Yes, 2 can. 15. Now 2 cannot already. So 3. 5. 3 cannot. So 5. 1. So the answer is 2 times 2 times 3 times 5. So 2 squared times 3 times 5. This is the answer. Product of prime factors. For 180, 290, 245, 2 cannot. 3, 15, 3, 5, 5, 1. So 2 times 2 times 3 times 3 times 5. So the answer is 2 squared times 3 squared times 5. Yeah, that's it. So these are product of prime factors. So you can tackle this question now. Written as the product of its prime factors, 1, 5, 1, 2 is written like this. So they tell you, they didn't tell you must do. They tell you 1, 5, 1, 2. If you were to do 1, 5, 1, 2, 2, 3, 0, 6, 2, 1, 5, 3. You got to do this. You're going to get the answer, right? So this is what they say. Right to 720 as a product of its prime factors. So you can do this. Try 720 as a product of its prime factors. So you write for me. Go and find out this one. Try. Okay, we do 720. For you not to go wrong, you always start with the smallest possible prime factor, 2. And you're going to get 360. Can divide by 2? Yes. Go on by 2 again. 180. Can divide by 2? Yes. 290. Can divide by 2? Yes. 245. Can divide by 2? No. Then the next prime factor, 3, 15. 3, 5. Can you divide 3 again? No. 5, 1. Stop. So the answer is 2 times 2 times 2 times 2 times 3 times 3 times 5. So that's 2 to the power 4 times 3 squared times 5. Yes, correct. This is how to get the answer. So that's very simple, isn't it? 1 mark. Done. B, giving each answer as a product of its prime factors, find the highest common factor. What is this? Let me just review. Let's say 12 and 20. What are the factors? 1, 2, 3, 4, 6, 12. For 20, 1, 2, 4, 5, 10, and 20. Right? Now I can ask you for the highest common factor. Highest common factor. Common means present in both. Let's circle all the common. 1 is common, 2 is common, 4 is common, and that's all. Well, which is the highest common factor? 4. Like that. Okay, this is how you do highest common factor. List all the factors and then go and look for the highest common factor. Like that. Yeah. So you try. You find for me the highest common factor of 24 and 16. Find the common factor for these, highest common factor. Okay, so the factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. Factors of 16, 1, 2, 4, 8, 16. What are the common factors? 1, 2, 4, 8. What's the highest common factor? 8. Okay, that's all. So that's a HCF. Now you bound to remember LCM. Excuse me. LCM stands for lowest common multiple. So these are multiples. So let's say I have 5 and no, I don't want 5. Say 3 and 8. What is the lowest common multiple? So you list what's common, what's multiple? Multiples, a multiplication table, timetable. So 3, 6, 9, 12, 15, 18, 21, 24, 27, so on and so forth. How about 8? What are the multiples of 8? 8 times table. 8 times 2, 16, 24, times 4, 32, 40, 48, so on and so forth. Now, what are the common multiples? You see the common multiples are 24 and more later. But this is the lowest common multiple. So the lowest common multiple is 24, like that. Yeah. So let's do 6, 3 and 6. Then you can see that there are many more common multiples. If you do 6, 6, 12, 18, 24, 30, 36, so on and so forth. So what are the common multiples? 6, 12, 18, 24, a lot, isn't it? So what is the lowest common multiple? The lowest is 6, like that. Yeah, so lowest common multiple and highest common factor. So let's go back to this question. How to find the highest common factor of 720 and 1512. So 1512 is 2 cubed times 3 cubed times 7. And 720 is this. 2, 4 times 3 square times 5. What are the highest common factor? What are common here? You can see the common ones are here. 2 cube is common and 3 square is common. There, right? Common. 5 and 7 not common. Therefore, 2 cube is 8. 3 square is 9. 8 times 9, 72. So 72 is the highest common factor of these two. Yeah, that's how you see. You see the factor here, 2 cube and 3 square are common. And so you multiply, get the answer there. Next. Find the smallest positive integer p such that 1512 p is a perfect cube. A perfect cube means times, this is a perfect square. Multiply 1 times 1 times 1. Perfect cube. 2 times 2 times 2. Perfect cube. 3 times 3 times 3, so on and so forth. Okay, now you look at this one. 1512 is 2 cubed times 5 cubed times 7 times p. Now, how to make this a perfect cube? Now, this 2 is already cubed. This 5 is already cubed. Now, this 7 can be cubed if p is 7 square, isn't it? 7 times 7 square is 7 cubed. And when you do this, you're going to get 2 cubed times 5 cubed times 7 cubed, and that is a perfect cube. So p is 49. There. Okay, so p is 49. And lastly, explain why a prime number cannot be a perfect square. Now we already settled about prime number. Prime number, how do you define prime number? prime numbers only have two factors. Itself and 1. How can it be a perfect square? Perfect square means like this: 2 square, 3 square, 4 square. These are perfect square. So your prime number can never be perfect square. And 1 square is 1. But 1 is not a prime number. So prime numbers can never be a perfect square. Okay? Now you look at this one. This chapter is called circles. I'm just going to discuss circles first, and then we stop it today. Yeah? Circles. So whenever we talk about circles, I'm just going to teach circles, and the next week we're going to do that question. Circle must have a center and a shape there, and it always has a radius. Double the radius is called diameter. So you only two things that they're going to ask you to find. One of them is area, and the other one is perimeter. But perimeter of a circle is a special name. They call it circumference. Same. But they never use perimeter. For a circle, they call it circumference. Where is circumference? Circumference is this red. Around, that's circumference. Where is area? Area is inside. The formulae are, for area is pi r squared, for circumference is 2 pi r. There are only two formulas to remember: pi r squared, 2 pi r. Primary school, you learned this already, yeah? So how to remember which is which? Because a lot of students forget, they get confused. One is pi r squared, one is 2 pi r. Which one is area, which one is circumference? They get confused. Now, if you recall, area, the units will always be centimeters squared, meters squared, kilometers squared. So the one with the square is the area. So this is area. That's how you remember. What is pi? Now, pi, there's a value in your calculator. You press the value will come out 3.142, etc. So pi can be 22/7 or 3.142 according to the calculator. It's always given. Then you use whatever is given there. So that's just how simple it is. So the area, let's try and find one you try and do for me. If I have a circle, radius 7 centimeter, can you find for me the area and the circumference? I give you pi to be 22/7. Let's try this. Okay, the formula for area is pi r squared. Yes, thank you. And the pi is 22/7 times radius is 7 times 7. So that 7 times 22 is 154. 154 unit or centimeter, whatever, right? So this is, okay, let's say this is centimeter, correct, centimeter. So this is the answer. But how to find the circumference? Circumference is 2 pi r, 2 times 22/7 times 7, 44 centimeter. Okay, good. So it's straightforward in the sense that you just have to do this. But how about if I give you this? And this is the radius, this is the angle. Now, how to find area, how to find they won't say circumference in this case, they will say perimeter. Let's focus on area first. How do you find area? This is called a sector, area of a sector. Now, area is pi r squared, area of circle, because this is part of a circle, if you recall. Now, but then this is not the whole circle, right? This is not the whole circle. Over 360. Okay, theta. Good, good. Yes, correct, Saki. So this is x, right? The angle divide by 360. Why the angle? Because it's part of the angle. It's just a part of it. And why it divide by 360? Because the whole thing is 360. So x divided by 360, you get this answer. Good, right? Oh, so Zaki, you know, very good. This is the area of the sector. Now, you can also be asked for perimeter. This one they can ask for perimeter. Now, what is perimeter? Perimeter has no formula. You just have to add all the sides. Perimeter, whenever you see perimeter, means add all sides. So what do you add? So you have to have this. This is R. This is R. So you know R plus R plus, what is this? Now, this is part of a circumference. Circumference is 2 pi r, just like just now. But this is not the whole circumference. This is an angle. So x over 360 times 2 pi r. Same as this. Notice? The only difference is this one has plus plus, because perimeter means add all the sides. Perimeter means you have this land and you want to build a fence. Where do you build the fence? You will build the fence here. You will build the fence here and the fence here. And so you have to add all that up. So r plus this, which is x over 360 times 2 pi r. Or in school or in the book, they sometimes call it theta. This one, right? Theta. Okay, so I'll stop here. Next week, we will do this question. Okay, thank you very much. Have a good weekend. See you. Bye-bye.